So patient weighs 135 pounds and is receiving medication via IV, which is 600 milligrams over 500 milliliters. Infusion at 20 milliliters hour per volumetric pump. How many millicentigrams per kilogram per minute is being given? And the conversion right here, millicentigrams or 1 millicentigram is equal to 1, I think that's microgram. So perfect. So we're going to start with the 135 pounds, or write down all of our information.
God, doing this with a mouse sucks ass.
Yes, it does.
All right.
So do you want to explain your process so far?
Yeah, so this one, I ended up having the question itself explain it to me. Mm-hmm. Basically, the question wants you to end up with mcg, Jesus Christ, over kilogram times minute. So you want pounds on the bottom because you're converting it to kilograms. And then on top of it, you're going to put one patient because you're talking about a patient. And then you convert pounds to kilograms. Pounds on top, kilograms on bottom. Jesus.
All right. Do you want me to write it?
Yeah.
Okay, perfect. Just tell me what you want me to write. So
you're right. One patient is per 135 pounds. Okay. And then you times that by the conversion factor for pounds. So like 1 kilogram is, I don't remember.
Yeah, the conversions you guys can look up, or you should have written down. So I won't put them necessarily because I don't want to give you the answers for these, just guide you through it. Okay, so we've converted pounds to kilograms.
And then it also gives you 600 milligrams per 500 milliliters.
Okay. So am I going to put that right away?
Yeah, okay. I think that's how I did it.
So 500 milligrams per 500 milliliters, or 600.
Okay. And so the question already gives the microgram conversion, or what mcg is. It's just micrograms. So then you put the conversion factor for milligrams to micrograms.
Okay. So milligrams to micrograms.
And while you're at it, you can just cross out pounds on both sides. And let's see. You can cross out milligrams on each side. Okay. And then you put the last one that they give you, 20 milliliters per hour.
So 20 mils.
And you can cross out milliliters next to 520. And then the last thing you need is just convert hours to minutes. So you put the conversion for hours on top, minutes on bottom.
Okay. Then hours cross out.
And that way you'll end up with one patient, which you can just kind of ignore the patient. It's so whatever mcg, I think, yeah, whatever micrograms over kilograms times minute. And you just have to find out the conversion factors.
Yep. And if you guys ask, well, technically we don't have mcg in our equation yet. 1 mcg equals 1 of these micrograms. So this is called a mu. So if you ever played Pokemon, the little pink mythical Pokemon Mew, it's what the sign is called. So yeah, So it's a 1-to-1 conversion. We could put it, but it's just extra work for us. Okay. So when I did this problem when I was in the class, the thing that tripped me up, the thing I couldn't wrap my head around to start, is this one patient over 135 pounds. If you don't know that you need to put this somewhere, then it's going to be very difficult to get it because the pounds needs to be on bottom. One way, or Nate, I'll answer that question real quick, or real soon. So one way to know how to start out if like pounds needs to be on top or bottom is to look at the units that need to be in the answer. So since kilograms is probably what we're going to be converting pounds to, starts on the bottom in our answer, then we know that pounds needs to start on the bottom when we start our equation. Because if I put pounds on top like this over 1 whatever, it's going to be very tricky to now get kilograms on the bottom because our pounds is already on top. So no matter what I convert with, so if I could convert pounds to kilograms is going to end up on top. So we want to make sure that our units are starting in the right place when compared to our answer. So then we'll check the chat right now. So Nate, I believe, said, what's the conversion to micrograms to milligrams? I think, let's see, let's do some maths. So I believe, so 1 gram is equal to 1,000 milligrams.
Yep.
Then 1 gram is equal to, it's either 10 to the 6th or 10 to the 9th micrograms.
I think it's 10 to the 6th. It's a mil, right?
Yeah. So 10 to the 6th micrograms. So when we're putting our conversions, we can just put these two numbers because we set them equal to the right thing. So we can just put 10 to the 6th and 1,000. So if you never know your conversion directly to two different units like this, if you know if you can convert it back to something you do know, you can make your own conversion or equivalency factor. Then, but you also see it, how would you multiply 500 times 10 to the 6th?
Calculator.
Yeah, calculator, or it's just, you can take it out of scientific notation. Your calculator should let you just put, so 500, then you could always do this, 10, then your calculator may have an exponent button, which may just let you put it like that. Or it'll look like 500 times like 10 arrow 6. Or you can take it out of scientific notation, which 10 to the 6 is 1,000,000. Then you just multiply it to 500.
You can always just do the tried and true method of just crossing out the zeros, which I think ends up being 1,000 micrograms to 1 milligram.
Yeah.
I think.
Yeah, it does. Or does it? Where I think it's 3 zeros left. Yeah,
something.
3 zeros left, 1,000 to 1. Yeah, I mean, at this point, it's just back to algebra. It's not really chemistry that much. It's just, and you can use calculators, so trust a calculator. 10 to the 6th is 1,000,000. 10 to the 7th is 10 million. So some common factors that you should remember, 10 to the 2, 10 to the 3rd, 10 to the 6th. So for a million, 10 to the 6th. So it's 1, then you add 6 zeros. this. So that's 1 million. So you had 6 zeros. The moving it after the decimal applies to scientific notation. 10 to the 6 isn't scientific notation, that's just exponents. So, yeah. Then another one, 10 to the 9th, which is just a billion with a B. Okay.
I have a question.
Yes.
Where did the MCG go in the equation? Because I don't see it. I just see kg, mg, ml.
So,
Yeah.
here. So right now in our long equation, right, we have this little symbol right here, which is micrograms, I hope, because that's what I've been saying. So that's micrograms. And we can look in our question that 1 mcg is equal to 1 microgram. So essentially we know that if we're in this unit right here, technically we are already in this unit, or the MCG, because we can just change it without really any consequences. If you want to show that you're converting, if you're converting this, you can put 1 MCG to 1 microgram, like that. But it's just a 1-to-1 conversion, so it's not going to change your final answer. It's just changing your unit really quick.
Oh, okay.
So that would cross that out, and we're left with MCGs on top.
Okay.
Yeah, I think MCG is just something they use in the medical field instead of this Greek letter that we use in science or like chemistry and biology. So I think they mean exactly the same thing. Why is the answer wrong? If your answer is wrong, make sure, so the math is going to be right. Make sure that they change these numbers. So they'll change 135, they'll change the 20, and they'll change the 500 to 6, or 600 to 500. So make sure you change those numbers accordingly, but the whole formula itself is correct. But, okay. So fuel tank holds 22.3 gallons of gasoline. If the density of gasoline is 0.8206 grams per milliliter, what is the mass in kilograms of gasoline in a full tank?
And it saved my work, so.
Yeah. So process here of doing this is to identify what your starting value is or what you're given. So 22.3 and 0.8206 are two numbers that they give us that we can choose to start with. The way we're going to discern it is two different ways. One way is you can ask yourself which one of these is an equivalency. Heather, my availability tonight is 6 p.m. to 9 p.m. Right after lab. So we can ask ourselves which one of these is equivalency. So 22.3 gallons, that just only has one unit. So we know that's not an equivalency. So it means we can start with that. Whereas 0.8206 grams per milliliter is, because it's saying for every 0.8 grams, it's equal to 1 milliliter. Another way that I like to try to figure these out is, what is our final end goal? So our end goal is kilograms, which is only one unit, right? There's no like kilograms per something else. It's just kilograms. So if we need to end with 1 unit, we're probably going to need to start with 1 unit. So gallons is a single unit, whereas grams per milliliter is 2 different units. So that's going to tell us that we want to start with gallons. So as Edgar has shown, we start with gallons. Then we need to convert to liters, then to milliliters. So we're able to use this conversion, this grams per milliliter conversion. So we need to figure out how to get gallons into milliliters. And once we've done that, we use our conversion right here. Now we're in grams, and we convert grams to kilograms. So all dimensional analysis is figuring out where you're going to start, where you're going to end, and just using equivalencies to try to make those fit together. It'll get a little bit more complicated when we throw in like chemical equations that we have to account for. But at the core of it, it's just converting stuff into other things, which we've been doing since like 2nd grade, when our teacher asked us to convert inches to centimeter, or like 1 inch to like a centimeter on a ruler, right? You looked at a ruler and you said, oh, the 1 inch is about 2.5 centimeters. That was elementary dimensional analysis. They posed it as pre-algebra or something. I don't know what they actually call it nowadays. But that's the same thing here. We're just expanding on that, on those methods. So it's not going to be your answer because they changed the numbers. But I'll explain the process that we're going to be looking at here and where to go. And Allison, yes, I would love to show you how to draw loose dot structures. Just I'll do it after this problem. So a patient needs 62.5 micrograms of Synthroid each day. The pharmacy only has Synthroid that is 0.025 milligrams per score tablet. How many tablets should be taken each day? So what we want to figure out here is what we're going to be starting with. So they're saying that the patient needs this many micrograms, right? And we can use this to convert it into tablets. And Dr. Henry is here. So hello, Dr. Henry.
Thought I was going to be able to sneak in.
No, of course not. It notifies us.
Okay.
So
you guys are finishing up the homework assignments. That's great.
yeah.
Good.
Okay. So I'll let you take over, Dr. Henry.
Okay. Are there any questions?
I have a question.
Okay.
For the discussion that you put on, and I know that it's due on Wednesday for
Mhm.
the dimension analysis, are
Yeah.
we supposed to like write a problem too? And then
That's right. That's
Oh.
exactly it. So you're supposed to write a problem, and then your colleagues are supposed to work through the problem. That's the idea.
Okay, is there a way like you could show us like an example or something that way we know like what kind of we have to do?
Yeah, sure. Okay, so this is just a simple conversion, right? So here you're going to be using dimensional analysis. I want, starting out with pounds, I want to know how much I weigh in picograms. So how would I go about doing that?
Pull out the information that you need to work the problem.
Okay, so let's get the information that we need.
Okay.
So what's our given?
That you weighed 153 pounds.
Okay, so I always believe that you should always start off with what you're given. I weigh 153 pounds.
Okay.
And then I go with conversions that I'm familiar with. So how many pounds equal a gram? Or how many grams equal a pound?
1,000, or wait, was it 2,000? 1 gram is how many milligrams, or what do we, or
No,
pounds?
grams.
Oh, how many pounds is? What? Oh, 1 gram is 0.002 pounds.
Okay. 1 gram is, you said it's, or is, so 2.2 grams is equal to 1 pound. Is that the same thing?
2.2.
Oh, sorry, kilograms.
Oh, okay.
But you're right. So it'll be 1,000 times that amount.
Mhm.
It's 2.2 kilograms. My bad. Okay.
Yeah.
Okay. And you said we also know how many grams are in a kilogram.
Yep.
How many grams are in a kilogram?
How many grams are in a kilogram? So kilogram, we have
Kilo. Somebody should tell me.
1,000
Yeah.
grams equal a kilogram.
1,000. Okay. How many picograms are in 1 gram? Pico. Anybody? Not 1,000. You want to go up a little bit higher. Actually, a whole bunch higher.
picograms.
So let me give you a hint. So a milli would be 1,000. A micro would be 10 to the 6. A nanogram would be 10 to the 9th. And then the next one would be a pico. Ooh, somebody got it. So that's 1, that's 3,
iPhone user.
6, 9, 12. Perfect. So 10 to the 12. Good job, iPhone. Okay. So all it is just kind of like putting like little pieces of puzzles together, right? So we got it. You guys already know that when you're doing with fractions, if you have something over itself, it cancels out. The goal is to cancel out the units till you get the units that you want. Okay. So if I have pounds, I can use my 1 pound. And that's going to be over 2.2 kilograms. Okay. So then that allows me to cancel out my units. I no longer have pounds. I now have kilograms. Simple so far?
Yeah.
Dr. Henry.
Yep.
I wanted to ask, on the discussion, do you only need to reply back to one person's question or to everybody's question?
So the goal is to give you practice. So you should reply back to at least 3 people's questions.
Okay.
Actually, you know, that's wrong. My equivalency there. Old age. .2 pounds equals 1 kilogram.
Wait, so 2.2 pounds equals 1 kilogram?
Yeah, 2.2 pounds equals 1 kilogram. Kilograms are less units than, make sure I'm not lying to you. One, yeah. Kilograms are less, so you would technically, yeah. Kilograms is going to be roughly, 1 kilogram is going to be roughly 2.2 pounds. So you're weight in pounds, right? So like if I was doing a personal ad and I weigh 220 right now, right? So then how much would I weigh in kilograms if I was doing a personal ad? Yeah.
Dr. Henry, can you put, would you be allowed to put the 1 pound and just whatever the equivalent of that kilogram instead of having a number on the bottom? Would we be allowed to leave the 1 on the bottom and just put the whatever the point blah 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 of kilo on the top?
That is the beauty of it. You could do it that way as well. So then you could just divide both sides by 2.2, and then you'd have 1 pound is over 1 over 2.2 kilograms. So whatever that value would be. Yeah, you could do it that way as well. And you guys, you'll find that there are multiple ways to get to the same answers. Okay, so we have pounds canceling out. How many kilograms? 1 kilogram to 1,000 grams. And we have, for 1 gram, we have 10 to the 12 picograms. Anybody gonna do all that hard math for me? Six. Okay, so we have 6.9 times 10 to the 6.9, so that's.
Dr. Henry?
Yep.
How did you get 6.9?
Actually, I did a little bit too much rounding, so it should be 6.95, right?
Yeah.
My bad. So it'll be 6.95 because it's 6.954545454545, right? So then we haven't talked about Sig Figs yet. That's what we're going to be talking about today. Is that correct? The rest of the day?
Right.
Good. I just want to make sure. Okay, so in this case, this guy would be 3 Sig Figs, and I'll explain that to you in a second. So then we would have 6.9 times 10 to the 16 picograms. So that's an example of me writing a problem, and then it's an example of me being another student and answering that problem. And the goal is that because chemistry is going to be you're going to be dealing with dimensional analysis all the time, consistently dealing with dimensional analysis. It's important that you guys get in a habit, and if you guys look at it in your Chem 101, they always have it set up that way. Get in the habit of doing it that way. I mean, I know you guys don't want to be individuals and you're like, well, oh, this is so much harder than, just simply doing it, but it keeps you in check in a sense. And it also allows you to sit there and check your units, right? Because a lot of times when I was doing problems as an undergrad, I would do things like, kind of like what I just did with the numbers, invert the numbers, right? Or I would invert the units. So I would put 2.2 pounds on top, 1 kilogram on the bottom. And then I go through and I do everything else right. So then keep everything else the same. And in this case, if I look at my units, my final units are going to be pound squared, kilogram squared, picograms. Is that what I wanted in terms of units?
No, you just wanted the picograms.
I just wanted the picogram. So that lets me know immediately that this is wrong. Right?
I have a question, Dr. Henry.
Yep.
The 10 to the 16th, that's 16 because with the answer that you got on the calculator, you had to go back the decimal, or I don't get how that's 16.
Okay, it's 12, right? This guy here is 10 to the 3, right? So 10 to the 12, this guy's 10 to the 3. So if I'm multiplying 10 to the 3 times 10 to the 12, what would be my answer? Anyone? Anyone?
Yeah, I'm getting 15 in my head. I didn't get
15,
the 16.
that's right. So 10 to the 15th. But then this guy is, Nate did the math for us. He got 69.5, right? So that's times 10, essentially, but 6.95 times 10.
Oh, and then you add that to it. Okay.
Yeah. So does that help?
Yes.
Okay.
It only works if it's 0, right?
What was that?
It only works if it's like 0.
What do you mean by if it's 0?
Like, you know how there's like 1,000 and there's the 10? I'm just wondering if that's like the only thing that decides the 16.
You're saying if it's all multiples of 10.
Yeah.
Yes, it works if it's multiples of 10. But you can do the same thing with multiples of 2. Let's say we had 8 plus 2 to the 4th, or not plus, times. Let's not do plus because that's a whole another issue. This is what happens when you're running in and out of places. Brain don't work completely. And let's say we have 2 to the 23rd. So then my answer would be, in this case, 2 to the, that's 27. What is, what can we break 8 down into? Isn't it just 2 times 2 times 2? Or 2 to the 3rd?
2 to the 3rd.
Mm-hmm. So if it's 2 to the 3rd, so that's 3, that's 4, and that's 23. So then that's what?
30.
30.
30. 2 to the 30.
Okay.
Okay. So you guys remember that from math a long time ago?
Yeah.
Okay. Questions, concerns, Cash?
Lots of concern.
That's all right. Don't worry about it. You're going to be fine. Just keep practicing.
How did you get 10 to the 16? After the 6.95 times 10 to the 16.
Okay. I got 10 to the 16th again because this guy here,
Yes.
153 divided by 2.2, that's going to equal 69.5454545, right?
Yes.
So that's the same thing as saying 6.95 times 10. Okay, so that's 10 times 10. So then I have it multiplied times 1,000, which is the same thing as saying 10 to the third power.
Yes.
And then this here is 10 to the 12th power, right?
Okay.
So if we look at the exponents, we have 12 plus 3 plus 1. What is 12 plus 3 plus 1?
16.
16. So then I get 10 to the 16th power. And then this guy stays in this form right here.
Oh, okay.
Okay.
My math was wrong then.
What was that?
My math was wrong. Then I divided 153 by 2.2 divided by 1,000, and that's how I got something different. But it was similar though.
Yeah. So, but you got to be careful. So, like what you said, you divide it by 1,000, right? But we know that grams are lower in units than kilograms. So it's going to take more grams to equal a kilogram, right? So you want to think about things logically. It's like, oh, okay, yeah, that's right. So 1,000 should be on top in this case because we want to get rid of kilograms. Here we get rid of pounds. Here we get rid of kilograms, and here we get rid of grams so that we can get picograms.
Okay.
Okay.
On the homework, everything it was starting good, but once I got to the conversions, I gave up.
Well, you don't give up. You're like, okay, let me try this again. Let me see if I can figure this out. And
I couldn't.
the key is using those little steps. Sometimes those little steps helps you out. Okay.
Yeah.
Also, like if you go to tutoring, it really helps out. I was having issues with a couple of questions, and even on a weekend, someone reached out to me. So you can send them the problem number that you're having with, and then they either will help you through every step, or they can give you the answer if you can't figure it out.
Oh, don't let them give you the answer.
Well, not like that, but they'll break it down for you.
Okay. I'm gonna get on these tutors real quick.
No, not like that. I promise you, Dr. Henry.
Okay.
Yeah, no, they broke it down and everything. So.
Okay. So let's talk about Sig Figs. Sig Figs are so much fun. You guys are gonna love them. Okay. And think positive.
Yeah.
Okay, so let's start it with addition and subtraction. First off, let's talk about what are significant figures, right? So significant figures are the numbers that we find to be important. So a lot of times in the scientific community, we'll collect data from different people. Like if you guys are going to be working as nurses, you're going to have a nurse that's on one shift, and then you're going to be on another shift. So you're going to have to be able to get the data that she had. Let's say you were monitoring a patient over a week or something like that. So she's collected the data for the time points that she had to collect data from, and then you're collecting it from another time point. And you want to analyze the data. You want to just take a look, kind of get a good glance at it. And so in that case, we want to sit there and pay attention to significant figures. So first, let's establish how we determine significant figures. So there's a couple of rules. And if you guys read in the book, and I'll go over the notes, it's actually in the notes as well too. So we have what we call, we'll start with the easiest one. When you have a 0 in between two numbers, all numbers are going to be considered significant unless it's a 0, unless that 0 is in between two different numbers. So then it becomes significant. Okay. So in this case, we have 1, 2, 3 significant figures because this 0 is in between two numbers. How many significant figures do I have here?
5.
5.
5.
5.
What about here?
7.
Okay. Simple, right? Not too hard. So anytime that you have zeros in between other numbers, they're going to be considered to be significant.
That's only if there's no decimal, right, Professor?
That's even if there is a decimal, how many significant figures are you going to have here?
Still 7. But like, how about if it's on the right side?
You're saying if it's on, you said the right side, right? So if I had zeros here, is that what you're asking me?
Yeah, like if it, for example, like if it's like 1,003,0076.
Okay, if I had 1 million. So how many sig figs would that be?
13.
Oops, short one. Now I messed it up. Oh, now 14, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 sig figs. But yeah, they still are going to be significant because it is still between numbers, right? Simple.
What if there's a 0 after the 6?
If there's a 0 after the 6, okay. So now here's the rule. We have what we call leading zeros and lagging zeros. Okay, leading zeros, that basically means that if we have zeros in front of a number here, these zeros in front aren't going to be significant. They're just being used as space holders so that we don't screw up the count of what it is. Okay, so these guys aren't significant. So then how many significant figures would I have here?
2.
Okay, this guy would have 2. We're going to use sig figs for the abbreviation for significant figures. Okay, and then if I have what they call lagging zeros, the lagging zeros become significant because we're telling the person who's in the next shift that this value here is accurate. We're sure about it. Otherwise, we wouldn't put it there, right? Would you put anything extra if you don't have to put anything extra?
No.
No. And that's the way you kind of have to think about it, right? You're not going to put that lagging zero unless you're sure about it, okay? So then you want to be sure that we're going to take that into consideration. So then how many significant figures would this be?
3.
It would be 3. Okay, piece of cake so far?
So far.
Yeah.
So far, good.
So far, yes.
What was that?
So far, yes.
So far. Okay, so although this here, these guys are also considered quote, lagging zeros in a sense. In this situation, because we don't have a decimal point here, or it's not in front of the decimal point over here, these zeros aren't going to be considered significant. Okay, so then how many significant figures do I have in this case?
1.
1. So these zeros are placeholders. They're letting us know that we have 100,000, right? And not that we have 1. You guys understand so far?
Could you repeat that?
I said these zeros are placeholders, meaning that they're holding spots, right? To let us know that we have 100,000 and not
Right.
that we just have 1.
Okay.
Okay. And this is the biggest mistake that all students make on the exams, right? Because I'll then ask them, what is the value of this? And they'll tell me 1, right? No, it only has 1 sig fig. It's still 100,000. Do you guys see the difference?
Yeah.
Okay, so let's see. Now we're going to test those skills, okay? Now, if we had put a decimal here and we're saying, oh yeah, I'm putting a point here to let you know that I'm sure about that 0 right there in front of me, okay? So by me putting that decimal there, that means that all of those zeros become significant. So then how many sig figs do I have?
6.
Okay, so if I put 0, 0, then how many sig figs do I have?
8.
8.
Or is it still 6? Oh,
Nope.
No, because you're sure. You put down 2 zeros because it continues.
Yeah, remember if I told you if you're putting down that extra, you're telling them, I'm sure about this, right? So if I put that decimal point there and I put down 0, 0, I'm saying I am damn sure about this.
Mhm.
Okay? Do you guys get that?
Yes.
Okay, so let's test out these skills. Hey, you guys ready?
Let's
We're gonna
do
clear the
this.
board. Okay, open up your mind, get ready. Okay, so how many Sig Figs do we have for the first one?
4.
4.
Right. 4.
Okay, we have 4. Okay, what about the second one?
5.
5.
5.
Say with confidence, 5. Yeah, I'm sure of it, 5, right?
Why is it 5?
Why would we write those extra zeros unless we're sure of it? Remember, we're all lazy. You can't pretend that you're not. You can't say, oh, I'm not lazy. No, everybody's lazy, right? So we're not going to do any extra work unless we're getting paid to do extra work, right? Is that true or is that false? Does anybody just like, I just like doing so much extra work because I just love doing extra work?
Only if I get paid for it.
Only if you get paid for it, right? Or you think it's going to help you in the long run,
Pay
right?
off. Yeah.
Right? It's going to pay off somewhere in the future, right? So these are extra zeros that are adding on afterwards, right? Right? We don't really need them to be placeholders. We're just using them to let us know that they're sure. We are sure about that value. We're really sure so much that we have these 4 extra zeros. So those guys are going to be significant. Does that help?
Yes.
Yes.
Okay. What about the next one?
7.
7.
The next one?
6.
6? You guys want to put money on it?
4.
No, that one should be 4.
Oh, 4. That's right. So only these first 4 are going to be significant. These zeros, those are not significant because we didn't put a decimal point there. So basically we're saying, you're telling everybody they're just placeholders and we're unsure about those numbers, right? Really, somebody probably rounded them up, you know, their scale was kind of crappy and it only went out so far, right? So then you're just like saying, well, I think they might be zeros, but I'm not 100% sure. It could be a 1 or it could be a 3 or something like that, but I'm not 100% sure because the scale isn't right, you know, or my whatever measurement we're using is right. Okay. Okay, so this last one.
6.
9.
9, that is correct. Because we took the extra time to put the decimal point and the 0, 0, 0. Again, you're not going to do it unless you absolutely must do it, right?
9. So the last
let me
2
ask
are
you,
true.
let me ask you this. So in this case, are these 2 numbers the same? Let's say I'm paying you. Are these 2 numbers the same?
No. I'm going to say no.
Yes.
They are?
I'm going to say no because
I'm
it keeps
gonna say
going
yes.
on.
I'm going to say yes because it doesn't have a decimal and it has the 2 zeros that you said are the.
Okay, so now remember, they have the same number of significant figures, but are these 2 numbers the same?
No, because
Oh,
the first
no.
one, the first one you were sure, so you cut it off or you rounded it, and then
That's
the last one you are saying to be continued or to follow through with it. It's going to keep going, but you're just holding places.
Yeah.
I thought you meant
So
significant
exactly,
figure.
these are placeholders. Those zeros are placeholders. They're letting us know. Let's say I owed you $130,300, right? And I paid you $1,300. Would you be okay with that?
No.
No, you'd be pissed off at me, right? You'd be like, you're robbing me, right? But I'll say, oh, you know what? But Sig Figs wise, you know. And then you'll tell me what?
Take your
So the
Sig Figs
significant
somewhere else.
figures are the same.
The significant figures are the same, but the numbers are not the same. Okay. And that's the thing that most students, they mess up on, right? Because they'll sit there and they'll do Sig Figs and they're like, oh, so then that means that this number is 1,300. No, it's not 1,300. This is 130,300, right? I used to love doing this in class because I'd make a lot of extra money. You know, I said, okay, so Sig Figs, penny, right? $1. You know, and if they got it wrong, it kept $1, right? Make sense?
Yeah.
Okay. Okay. Let's see. So now that's the easy part, right? So this is just understanding how many Sig Figs are. Pretty easy, you know? Okay. We're going to come back to this because I want to test out those skills here in a second. But let's talk about addition. So when we're adding, because we're going to be taking data from other places, sometimes we have to add that data together to get answers that we want. And so we have to get a way of determining the final number of significant figures based upon a lot of different data, okay? So let's say we're taking, I don't know, weights of different things. So one was 120, 120.79, 113.654, and we'll do 100.
What is that? Is that a 120.79?
79.
Okay.
Sorry, my handwriting is like a third grader's. Okay, so the way that we go about sitting there determining the number of significant figures, first off, let's talk about the significant figures of each of the different numbers that are up there. So we'll do that, and this is just for our benefit, so that we keep that practice going, okay? And then I'll show you how to do it for when we're doing addition and subtraction. It's pretty much the same one. So how many Sig Figs do we have for the first one?
The first one you have 2.
2.
The second one?
4.
5.
Or I mean 5. Sorry.
5.
The third one?
6.
6.
And the last one?
1.
1.
I got that one.
Okay. Darn it, I thought I was gonna throw you a curveball.
I'm getting better.
Yeah. Okay, so now the way that we set this up is that I like to do it by drawing lines because I'm a very, very visual person, right? And so it makes sense for me to sit there and draw lines. You may not have to do that because you're like sharp, but I'm not as sharp as you, so I like to draw lines. So the way I do it is I sit there and draw significant figures. So based upon where the number of significant figures ends, I will draw a line. So in this very first one, we're going to draw a green line. So we said the first 2 numbers are significant, but that 0 isn't, right?
Mm-hmm.
Is that what we said? So then I will draw a line right there.
Mm-hmm.
Okay, for the second one, we said that all 5 numbers are significant. I'm going to draw another line in a different color. So, okay. And then for the third one, all of them are significant again. And I'm going to draw another line and another color. And then for the last one, we said, how many are significant?
1.
Yeah.
Only that first one. Okay, so what we're going to do is, now that we sit there, we've drawn our lines, we want to go to the furthest to the left, right? Line, right? So in this case, these guys, the ones that shared furthest to the left is the brown line. So all of these rest of these guys aren't going to be significant. So then I'm just going to erase those lines because only the brown line is the one where we're going to determine significance, right? So let's go ahead and do the math. So this is all addition, so it's plus. So if we added this up, that's what, 4, 4, 4, 4. Man, that was random. 5, 4. Okay. Okay. Now let's talk about rounding, right? Because that's what we're going to do. We're going to do some rounding. So we have only one significant figure. So we want to write our answer so that there's only one significant figure. So the way that we sit there and determine whether or not we round up or if we leave it that number alone and just put zeros there is that we look at the number that will be on the other side of the line. So in this case, we have a 5. 5 is kind of a funny one, right? And depending on the book that you read, like your textbook, part of your textbook says one thing and part of your textbook says another thing. So when you look at the number 5, if it's 5 exactly, 5 and there's no numbers following it, so if this was all zeros, then in that case, then you would actually round down. You would say it's 400. I mean, the answer would be 400. Since there's numbers following this, we look at this 5 and we'd round up. So 5 is that break point. Either we're going to round down at 5, or meaning round down, meaning we're putting zeros there, or we're going to round up. So if we round up, this value would be 500. So for this answer, the answer would be 500. So if it's 5 exactly or less, then it's going to be rounded to 0. So you just put the zeros there. If it's 5 greater, then you're going to round up. Does that make sense? Or am I just kind of
I have a question.
making it hard? Yep.
Why are we rounding to 5? Like, how come we're not rounding to, like, I don't know, 455? Why are we rounding to 500?
That is a good question. You asked, guys, it's like you guys were prompted to ask all the right questions. Okay, so let's talk about it. Because this number here is so, we're not so sure about it, right? We're not 100% sure about it. This guy could be 3. It could be 4, this 0 here. It could be anything that's less than 5. It could be 5 exactly, right? So if it was 5, then this number would definitely be a 5, right? If that 0 was. But we don't know about that 0. We don't know if it was a 5. We don't know if it was a 4. We don't know if it was a 3, right? Because those numbers weren't significant. So the person that wrote it down, they did a quick job. Their scale didn't work or something like that. They said, okay, 100. I don't know, it may be more, but I'm not 100% sure. So they just wrote down 100, right? And they didn't put a decimal point. So that meant that these two digits, we don't know anything about. This guy could have been a 9. It could have been a 1. This guy could actually been, really, it could have been 99, 9, you know? And then they just decided to round up to 100 just because they were lazy, you know? There's so much uncertainty about that number that we're trying to account for that uncertainty. Do you get it, what I'm saying?
Yeah, so that line that you drew from top to bottom, that it's almost like kind of representing a decimal point in itself, kind of just for in your mind set to, okay, I get it now. It's in my mind a certain way. Okay, I get it.
Yeah, exactly. So it's not like it's not a true decimal point, but it's letting us know that is the line where we decide whether or not we're going to round. So we use that very next number to determine whether or not we're rounding, right? So this is my decision line. Okay?
Okay, I get it.
Okay. Piece of cake, not too hard?
I don't know about piece of cake, but I get it.
Okay. So you want to try one more?
Yeah.
Yeah.
Sure.
Make it a little more challenging.
The hardest one you have.
Oh, I have really hard ones.
Just make it test appropriate.
They're all test appropriate.
Like
if it goes on the
exactly.
board,
No.
If it goes on the board, it's test appropriate, right?
Not Einstein appropriate. Test appropriate.
Okay. Gonna do addition again. Okay, so how many sig figs do we have here? The first one.
5.
3.
let's see. I'm in a little trouble right now. Okay, sorry, I paused my screen. So Sig Figs. How many? This
5.
first one?
A 5.
5.
Okay. The correct answer is 5. What about this next one?
3.
Mhm.
3. What about this next one?
2.
2.
What about this one?
4.
Mhm.
And the last one?
3.
3.
Simple so far?
Yes.
Okay, so let's draw our lines. So let's start with this, the first one. Where would I draw the line at?
The last, all the way at the end of the 0 on the right.
Okay. Okay. What about the next one?
After the 3 on the right.
After the 3?
Yeah.
The 0.
Should be after
It's
the
after the 0. Yes,
I
because
mean-
that's a significant one. Yep.
Yeah, sorry. I got everything all not lined up correctly.
I know. You'll get used to my craziness. Okay. The next one.
After the 9.
After the 9. Okay. The next one.
After the 0 on the right. Which,
Which we already have with the red.
yeah.
Do we?
Yeah.
Uh,
No. Could we put X's if it made it easier for us, like as placeholders?
Yeah, you can. And then the last one.
after the 0. The last
After
one.
the 0 on the right.
Right here. Okay. So what is going to be my decision line?
The furthest to the left, which will be after the first 2 digits.
Okay. So what color is that?
Black, green,
Green.
Anybody colorblind?
dark green.
Okay, dark green. Okay. Okay. So now we can do the math. So we have what? 0, 0, 6, 7,
2 and 4.
2, 4. And our decimal point would be right here. Okay.
So it would be 43.
That is correct.
Yes.
So the answer would be 43. And how many sig figs would that be?
2.
That is correct. Simple?
Yeah.
And so we're doing it on our own.
Okay, so the same thing applies with subtraction. Subtraction is going to be exactly the same way. Okay, so let's do a quick one. So we'll do.
Sorry, just quick question really fast. If you were gonna write that, digressing, if you were gonna write 43 with 2 sig figs, how would we write it? Just like I said it?
You just write it 43, right?
And if you
Let's-
ask like how many sig figs, just put 2 sig figs. So
Yeah, you
43
write
comma
2 sig figs. Yep.
Okay.
Or 2 significant figures. If you're going to be. So.
Okay.
Okay. So what are we going to do in this case? Oh, let me add one more letter, one more thing to subtract. Okay.
Let's counter sig figs.
Okay. How many sig figs do we have for the first
The first one we have 1, 2, 3, 4, 5.
5? Okay, Yari, we'll figure something out so that we're not going to just use the color. I'll make a like heart, diamonds. You can tell the difference between hearts and diamonds, right? Second one.
3.
And the last one.
1.
Good job. Thought I was going to get you again. Yeah, you guys are good. Okay, so if we draw our lines, we'll start with the first one.
After the 0 on the right.
After the 0. Okay. How about the middle one?
After the 0 on the right.
Okay. And
Last one's already there, right?
the last one is the same one. It's the red one, right? Okay. So which line are we going to use?
The line on the left.
heart?
Diamonds.
Our girl's best friend. Okay.
Yeah.
Okay, so if we do the math, okay. So how many sig figs should we end up with?
You end up with 4.
Are you sure?
End up with 3.
Oh,
We're going to end up with
yes.
3.
3.
That's right.
Precision line.
Yes. Okay, so are we going to round up, round, or leave it alone?
300.
Round up.
Okay, so you guys, so we'll say, we'll put 2 options. Somebody says it would be 0.300. Or would it be 0.299?
Was 0.
I still think 300.
No, 0.300.
Just to clarify, are we rounding up based on what's on the opposite side of the on the decision line? Okay.
We're rounding based upon what's on the decision line. Right?
That's
On
going to
the
go
other side of the
down.
decision.
It's going to go down. So it would be 5 or so 0.299.
Okay. So
0.299.
So we're going to wrap this up real quick. So the question is it going to be 0.299 or is it going to be 0.300? So the answer is, are there any numbers following this 5?
No.
No. So is that an exact 5?
It's exact then.
Yes.
It's right at 5. So
Oh.
5 is our decision point, right? So if it's above 5, greater than 5, we always round up. It's exactly at 5. So in reality, you're supposed to, right? And this is what I said in your book actually has 2 different ways of doing it. It has one where if it's at 5 exactly, you don't round up, you leave it alone. So the absolute correct answer is this. So in this case, it would be 0.299. Let's say if we have a 01 here, then we'd round up because it's greater than that 5. Do you understand?
Yeah, but I was always taught that 5. I mean,
I know. I know, but I'm just telling you, in science, right? And like I said, it depends on the book that you go from. But scientifically, that 5 is the midpoint. So that is going to be your decision. So if 5 itself is exactly 5, then you're going to round, you're going to leave it alone. But if it's at 5 or anything following it, then you're going to raise it up. So
Dr.
greater than
Henry?
5, yeah.
Okay, so you wrote 501. So it's basically any numbers thereafter that 5,
Yep.
that it's going to make it be considered to be higher or lower. So it's not necessarily just only the number to the right of that 5, because
That's
you
right.
get what I mean? Okay.
Yes.
It's just
yes,
like any
exactly.
number.
Yep.
Okay.
Yeah. And it's kind of like, okay, so if you guys are like, have you like, you have a scale that is completely balanced, totally balanced, right? It's right there in the middle, is perfectly balanced. And you put like one little speck of dirt, what happens to that balance? Doesn't it shift?
Yes, because it's greater.
Yeah,
By a
because it's
speck.
greater. So that's exactly the same concept.
Okay.
Okay.